Good day to everyone. We are from Group 2 for Microeconomics Group H. Today our group will present Module 5 questions C, D, and E. Before start our presentation, I will introduce ourselves. First is Call Chi Chen. His mental number is D20251111X604. Second is No, I know Patricia binti Mos Sabrin. Her mental number is D2025118598. Third is Arjuna Vanjana binti Rosran. Her mental number is D20251111X600. Last is me. My name is Lo Chi-en and my mental number is D202511118598. Now I will pass to my group member to start our presentation.
For question C, these questions want us to show that the marginal productivity for inputs K and L is diminishing. Okay, so first is given Q is equal to K plus L plus 2 square root KL, and then K plus L plus 2K power 0.5 L power 0.5. Okay, the marginal product of the input can be found by taking the partial derivative in the right side, and then the second derivative can be taken to show that the value is negative. If we want to show the marginal productivity for the inputs is diminishing, we have to find the second derivative, its negative values. Okay, so now for input K, MPK is equal to partial Q over by partial K. So it's equal to 1 plus 0.5 times 2 K power negative 0.5 L, L power 0.5. And then 1 plus, the final answer is 1 plus K power negative 0.5 L power 0.5. And so for the second derivative, we have to take the first derivative, which is in the upside, the 1 plus K power negative 0.5 L power negative 0.5. Okay, so now we have to put the negative 0.5 to in front of K, so it can be negative 0.5K, and the power we have to minus 1, so it's negative 0.5 minus 1, so it will be negative 1.5. Okay, so the one we have to subtract. Okay, so now it be negative 0.5K power negative 1.5 L power 0.5. Okay, and then it will be negative 0.5 L power 0.5 over K power 1.5. Okay, so since it's negative, so its negative value is smaller than 0, so it shows that the MPK is diminishing.
Okay, now we're going to moving to question D. Okay, the question asks us to show this function, which is a production function, exhibit constant return to scale. Okay, this means that if we increase all input, now we have K and L. K equals to model input and L equals to label input. So we actually if we increase all input by a certain factor K and L, the output, we want to make sure that the output will increase by exactly same factor. Okay, we look at the production function. Q equals to F in a bracket of K, L equals to K plus L plus 2 the power of KL. So we want to show that the exactly production function exhibit the constant return to scale. Oh, before we start, if you saw this symbol, like V terbalik, if you saw that, this is exactly called, the symbol is called lambda. This symbol is Lagrange multiplier. If you actually this symbol this symbol exactly says, if you are maximizing your utility subject to a budget constraint, the value of lambda tells you exactly how much additional utility you would gain if your budget were increased by $1. This is the function of lambda. Lambda doesn't have any exactly number. It doesn't actually this like it uses like X and Y symbol, doesn't have a number, doesn't represent any number. So lambda is just what we showed is Lagrange multiplier. To test if we get the constant, if the original production function get a return to scale, so we scale both of the input, which is K and L, by a factor of lambda. So we substitute K with lambda K and L with lambda L. So we get F in a bracket of the lambda K lambda L equals to lambda K plus lambda L plus 2 source of power lambda K times lambda L. Okay, next, let's take a look at step 2. But now, we want you to focus at the number of two source of power in the bracket of lambda k and lambda k times lambda l. Okay, we want to make it easier by when we multiply the lambda k by lambda l, we will get lambda the power of 2. We want to make it easier, so we will multiply the lambda k by lambda l, and then we get lambda the power of 2. Okay. Now we will get f in the bracket of lambda k lambda l equals to lambda k plus lambda l plus 2 source of power lambda the power of 2 times k l. If you put the number, if you put in actually calculator and calculate it, it's not exactly calculate. When you just imagine that lambda we represent 1. So if you put in calculator 1 and the power of 2, you will get 1. So lambda, since the square root of lambda is the power of 2, so you will put in calculator, you will get lambda. Lambda is 1, just like that. Now we can pull it out of the square root sign. So you will get f equals to f in a bracket of lambda k lambda l equals to lambda k plus lambda l plus 2 lambda source of power k l. Okay, step 3. Now we can see that lambda is a common factor in every input. You will get lambda. So lambda is a common factor in every term or every input. Like k, now you get lambda k plus lambda l 2 lambda the power source of power k l. So now we can factor it out of the expression. Now you will get f in the bracket of lambda k lambda l, you will get lambda in the bracket of k plus lambda plus 2 the source of power k l. After you factor it, you will notice that this expression identical with our original production function f, which is f in a bracket of k l. You will get now f in the bracket of lambda k lambda l equals to f lambda times f in the bracket of KL. So if you saw that f in the equals of lambda k lambda l, exactly you will get k plus l plus 2 the source of power KL. Exactly same you will get when which original function, which is f in the bracket of KL. Okay, this show that when we multiply our input, which is k is model input and l label input by lambda, the total output is also multiplied by lambda. This proves that the function exhibits constant returns to scale, meaning that the output increase in exact proportion to the increase in input.
Hello everyone, my name is Nur Ainul Batusha binti Muhammad Safi and my matrix number is D202511185595. I would like to continue the presentation by explaining question E. So for question E, does this production function show a complementary relationship between inputs K and L? The answer is yes. This is because the term 2 square root of KL in the production function indicates that K and L work together in the production process. An increase in K increases the contribution of L to output and vice versa. Therefore, these two inputs complement each other rather than acting independently. In conclusion, this production function exhibits marginal productivity, constant returns to scale, and complementary relationship between inputs K and L. Thank you for your attention. That's all from our group. Thank you.